I'm going to work out three problems that relate to remainder and factor theorem to show how these theorems can get used in some creative applications. So first problem is going to be this. I'm given this information. When kx squared, cubed rather, plus mx squared plus x minus 2 is divided by x minus 1, the remainder is 6. When it's divided by x plus 2, the remainder is 12. The goals are find k and m. So, dividing by x minus 1 is like substituting 1 into the function. The fact that the remainder is 6 means that I'll get 6 as a result when I do that substitution. So I've got k times 1 cubed, m times 1 squared, plus 1 minus 2. Simplifying that, I can write k plus m equals 7, which is one equation. Now, using the second piece of information, substituting negative 2 results in 12. So I'm going to do the same process with a substitution of negative 2. And when I simplify and rewrite that, I'll get negative 8k plus 4m equals 16, a second equation. Okay? Now, from equation 1, I can isolate for k and say that k is 7 minus m, and substitute that into equation 2. So equation 2 is going to be negative 8, replace k with 7 minus m, and leave the rest as is. And now I just need to expand and gather terms and isolate for m. So I've got 12m equals 72, m equals 6, and k is 7 minus m, so 1. That's that problem solved. m 6 and k 1. A second problem is the following. Find the missing factors. Given x exponent 5 minus 8x exponent 4 plus 25x cubed minus 38x squared plus 28x minus 8 equals x squared. Put my signs backwards on this. I want minus 3x plus 2, and then there are 3 factors that need to be found. Okay. So, first of all, we need to recognize something. We need to recognize that x squared minus 3x plus 2 can be rewritten. Think about how. You might want to pause it, consider it, and then come back. What I wanted you to find was that it can be factored into x minus 2, x minus 1. So we've been given 2 factors just sort of hidden. What I'm going to do is use synthetic division with these. So I'm going to use the negative 2 value. I'm going to detach all the coefficients from the dividend, which I'm doing now, and I'm going to perform synthetic division. So negative 8 subtract negative 2, negative 6, continuing to multiply and subtract. I'm going to get remainder 0, which is what I would expect. So this is the quotient. Now further, I'm just going to do another division with negative 1 on that quotient. I can keep going to break this down even further. So this leads to the next level of quotient using the second factor, which I'm discovering right now, and also a remainder 0, confirming that x minus 1 is a factor. What I now have is x cubed minus 5x squared plus 8x minus 4. This needs to be factored into 3 binomial factors. Looking at the negative 4 constant term, its factors are plus or minus 1, plus or minus 2, and plus or minus 4. So those would be the ones I would test on factor theorem. Trying f of 1 leads to 1 minus 5 plus 8 minus 4, which is 0. So x minus 1 is a factor of the quotient, the cubic quotient. So I actually have an x minus 1 factor twice now. So let's do synthetic division on that. There's my x minus 1, and these are the detached coefficients of the cubic that I am working with. And I'll perform synthetic division. And I will arrive at 0 remainder, which confirms that that was a factor. My quotient now is x squared minus 4x plus 4, and I have means of factoring that because it's quadratic. It's x minus 2, x minus 2, or x minus 2 all squared. So the three factors that I wanted to find are x minus 1 and x minus 2 squared. A third example. Okay, in this problem, we're told that x minus a is a factor of 2x cubed minus ax squared plus 1 minus a squared x plus 5, and we want to find a. Well, the fact that it's a factor tells me that f with a substituted gives a remainder 0. So let's substitute a into the expression that I have, and then we'll simplify it and see what we arrive at. So I've got 2a cubed minus a cubed plus a minus a cubed plus 5. Now you'll notice 2a cubed minus a cubed minus a cubed. All the a cubes are canceling, leaving only the a and the 5. So a is negative 5. That fell apart quite quickly. I'm going to give you one more example to do. I want a factor to solve 6x cubed minus 5x squared minus 12x minus 4 equals 0. So I'm going to look at the negative 4 constant term, think about its factors, plus or minus 1, plus or minus 2, plus or minus 4. Just looking at 1 very quickly, we can do mental math and find out that 1 isn't going to work. A substitution of 1 itself is like ignoring the x's and just dealing with the coefficients. Negative 1 would change the sign on the first term, and the third term, again, it won't work. So let's try f of 2. F of 2 is going to look like this. Now, by the way, you should always start with the simplest numbers and work toward the hardest. Always start with 1 and see if it works. You're just doing yourself a favor when you do that, making life a little bit easier. Okay, this expands and simplifies to 0. So x minus 2 is a factor, I've just found out. Good. So what I'll do now is synthetic division with the negative 2 and the detached coefficients of the dividend. And we'll see what we're going to get here. We should have a remainder of 0. And we do, confirming that x minus 2 is a factor. So my quotient is 6x squared plus 7x plus 2. Now, there's a little trick we can do, dividing by 6 and multiplying by 6 on the end. This isn't an equivalent polynomial, but it sure makes factoring easier. X and 3, x and 4, and now I will divide each by the 6 that I divided out before. Simplify and write x plus half and x plus 2/3. So the trinomial, or the, pardon me, not the trinomial, the cubic that I had can be rewritten using these three factors: x minus 2, x plus 1/2, and x plus 2/3. Now, notice that if I were to multiply this out, I would actually get 1x cubed. And the original problem had 6x cubed. So this isn't virtually equivalent. What I would actually do with these is I would multiply by the denominator to get the 2x and 1 and get the 3x and 2. But either form that I just wrote or the form that are in brackets are going to have the same zeros. This leads to the zeros of x equals 2, negative half, and negative 2/3. You can check this by graphing on your calculator.